Hello everyone and welcome back to our YouTube playlist. In this video we are going to discuss operations on singly linked list. The agenda of this video is insertion, insertion of node at the front, insertion of node at any position in the list, and insertion of node at the end. Then we are going to discuss deletion, deletion of a node at the front, deletion of a node at any position in the list, and then deletion of node at the end. Now, before moving further, let us discuss some of the basics that we have already covered, which will be required in this entire video. So in linked list, we declare our own data type, which is struct node. And since any node contains two elements, which is the data part and the pointer part, and since the pointer points to the next node, hence we write in data and struct node star next. So what we have done so far is we have just created our own data type struct node. We have not created a node yet. The memory has not been allocated yet. So to create a new node, we use dynamic memory allocation, that is malloc function in C, while in C++ we can also use the new keyword. Now, since any node has two elements, which is the data and the next, here we initialize the data part of the new node to 10 and the next part of the new node to null using the arrow operator. And when we write head equals new node, it essentially stores the address of the new node into head, which means that the head pointer will now point to the new node. So what we have done so far is we have created only one node in the linked list. Moving ahead, let us first code whatever we have done so far. I'm going to use online compiler and the language that I'm going to use is C++. So let's get started. The basic formalities, I'm sure you have written this many times. Also, I'm going to use C as my language. You guys can use C++ as well. Yeah. So as I mentioned earlier, there might be cases where we have to insert a node, or there might be cases where we have to delete a node. So for that, let us declare two functions that will take care of that, and after each iteration we have to show the list. That's we have to display the list, and to display the list we have to first traverse the list. So let's declare that function that will take care of that. Let's also let's make this program a menu driven, because we have to ask the user for his choice whether he has to insert a node or has to delete a node. And since we have to traverse the list, we need some variable to go through the iterative approach, that is go through the for loop. So let's say that variable is I, and pause, and let us write item. So pause will take care of the position, that is the position where we have to insert or delete, and item will take care of the data part of a particular node. So let's define our data type, which is struct node, and any node has two parts, that's the in data and struct node star, that's a link, I'll point it to the next node. I'm also declaring the header, then a temporary pointer ptr, another temporary pointer ptr1, and new node. Now you'll understand this in further parts of this video. So let's define our main function, that is the entry point to our program, and also let us initialize the header as null and the temporary pointer ptr as header, which is also null. Since this is going to be a menu driven program, let's make it 1 menu, and let's display the choices that the user has. So first is insertion, second choice is going to be deletion, the third choice is to display, and the fourth choice is to exit from the program. Also let's ask the user for his or her choice, so %d, and because we have used the choice variable, so choice. Now let's start with the switch case, choice, and the case 1 must be insertion, so insertion function must be called break. Case 2 is to delete, so the deletion function must be called break. Case 3 is to display, so the traverse function must be called, and case 4 is to exit. So let's display a message, let's say thank you, exclamation mark, and exclamation mark. And also let's keep this inside a while loop so that user can insert multiple nodes, or if he wants to, or he can also delete multiple nodes if he wants to. So for that, let's use d equals 1, and when if he has to exit, then d equals 0, and then we'll simply break. Last case will be the default case, where we will display wrong choice. \n \n, right. So far so good. This is closed, this is closed, and the main function is closed. So this is the menu driven part of our program. Now let's understand how to insert a node, then we will understand how to delete a node. So let's understand insertion of a node at the beginning. First, we create a new node with the data part as, let us say, 10, and there might be two cases here. First case is when the head equals null, and second is when head is not equal to null. So when head equals null, that is when the list is empty, then we point the head to the new node itself, right? And if the list is not empty, that is head is not equal to null, then we first create a link between our new node and the first node of the list, and then finally the head should point to our new node. So this is the algorithm. If the head is null, then head equals new node itself, that is we simply point the head to the new node, which means that the new node is the first node of the list, that is the list was empty, and then we have created the first node of the list. Else, if head is not equal to null, that is list already has nodes, then the next part of the new node must be equal to head, which means that the next part must point to the first node, and then head equals new node, which will make our new node the first node of the linked list, which means that we have inserted the new node at the beginning of the linked list. Now let's code what we have understood till now. Let's define our insertion function. And to insert a new node, we first have to create a new node. So to create a new node, we use the dynamic memory allocation. So malloc size of struct node. Now we have to ask the user for the item to be inserted inside the node. Let's enter the item to be inserted. Scanf will be using the global variable that we have already declared, item, this variable, and then we have to write new node, the data part of that new node equals item. Now the next step is to check whether our linked list is empty or not. So to do that, we do header and we check if header is null. So if header equals to null, it means that our linked list is empty, which means that the new node is going to be the first node of the list itself. So the new node should have its link part pointed to null, and header must point to new node. Else, if the linked list is not empty, that is if header is not equal to null, then we have to ask the user at what position he or she has to insert the item. So let's ask, enter the place to insert the item, And let's also display the different positions, that is start, and the second position is going to be at some point in the middle or at the end. Let's take the choice. Yeah. Now if choice equals 1, that is user wants to insert the node at the beginning, and also because we are in the else, it means that the linked list is not empty. So in this scenario, we'll point the link part of the new node to where header was pointing, and now header must point to new node. So this is what we have seen in this particular algorithm, right? The link part or the next part of the new node must point to head, and head must now point to new node, and that is what essentially we have done here. Else if choice equals to, it means the user wants to insert the node at a particular position in between the linked list. So let's understand the logic behind the same, that is to insert a node at the given position, and then we'll code what we have understood. Consider this as our linked list, and this is the new node which we have created, and the value of the new node is 50, right? So the problem is to insert this particular new node at position number 3, which means that if this node is considered at position number 1, then the new node must be at this particular position. Also, this means that we have to traverse the linked list, and to traverse the linked list we have to create the new pointer, which is ptr, because we cannot use head. Otherwise we will basically lose the link to the very first node itself. Now the algorithm, we will use the for loop, which will traverse from the first node or the first position to position -1, or to the node after which we have to insert a new node. So once this for loop is terminated, the pointer ptr is at the node which is just before the position where we have to place the new node. Hence, we have to create a link between the new node and the node containing the value 30. And as a final step, we have to create a link between our current node and the new node. And this is how we have inserted the new node at position number 3 of this particular linked list. Now this is the algorithm that we will be going to use in our code. So once we have understood the algorithm, let's now code in the compiler. To begin with, first we have to point the temporary pointer to the first node, and then we have to ask the user for the position, right? So enter the position to place or insert the item. Scanf, we will be using the global variable. Pause, and now we are going to traverse the linked list. So again the global variable from starting from 1 going till pause -1 and then I++. Now since we are traversing, we will write ptr is equal to ptr next. Now again telling why pause -1, because the pointer after the iteration or after the for loop must point to the node which is just before the position where we have to insert the new node. That's why it should be pause -1. So after the for loop is over, we should write new node. The link part of the new node must be equal to the link part of the pointer, and now the link part of the pointer must point to the new node itself, right? So that is probably it, right? Yeah, so that is how you insert a node at a particular position. Now the last case might be choice equals 3, that is to insert a node at the end. So for that, let's understand the logic and then we'll come back and write in the compiler. Consider this as our linked list and the new node that we have created. We have to insert this new node at the end of the linked list. To do this, we have to get to the last node of the linked list, and to do that we have to traverse the entire linked list. And as mentioned earlier, to traverse any list we can't use the head pointer, otherwise we will lose the link to the first node itself. Instead, we create a new pointer, let us say ptr, and then traverse the list until we find a node whose next part is null. That is, until we find the last node. The last thing to be done is, so this is how you have to traverse till the last node. And then the last thing to be done is to change the next part of this current node to the new node, which will now become the last node of the linked list. So this is the algorithm, and let's code what we have understood in the compiler. So to begin with, pointer must part to the first node, that is where the header is pointing, and then we are going to traverse the linked list until we reach the last node, that is link is not equal to null. So to traverse, we are going to write ptr is equal to ptr link, and then once this while loop is terminated, the pointer is now pointing to the last node, and then we have this new node. So new node, link part of it must now point to null, and pointer's link part must be equal to new node, or must point to the new node. So that is going to make the new node place at the end of the linked list. Now we are done with the insertion function. Let's define the deletion function. So void deletion. So let's first point the pointer to the first node, that is to where the header is pointing, and let's check if our linked list is empty or not. So to do that, we will write header is equal to null. And if header is equal to null, it means that the linked list is empty. That is, there is nothing to be deleted from the list. Hence, we will simply printf that the list is empty. Else, if header is not equal to null, it means that the linked list has nodes inside it. So first we have to ask from which position you have to delete a node. So there might be three cases, that is from the start, the second case might be from the middle, and the third case is from the end. So we accept the user's choice, that is, let's write enter the place to delete the element from list, and that should be printf, and then in the scanf we will accept the position, the global variable pos. Oh, it should be choice actually, right? So again, if choice equals 1, that is the user wants to delete a node from the beginning, the starting node itself. So first let's understand the logic to delete the node at the beginning, and then we'll move on to write the code in the compiler. So deleting a node at the beginning. To delete a node in a list, we first need to check whether our linked list has got a node in the first place. That is, whether the list is empty or not. If it is empty, that is the head points to null, then there is no requirement to delete a node, and we will simply display that the list is empty. So let us suppose that we have this linked list and the head is pointing to the first node. Now we want to delete this particular node of this list. For this purpose, we need to create a pointer ptr which must point to this first node of this list, and we have to move our head pointer to the right so that it could point to this particular node of this list. Now why this step is required? Because we can see that this node is to be deleted, and if the head is still pointing to this particular node, then it doesn't make any sense, right? Here the head pointer must point to the second node of this list, because after deleting the first node, then this node becomes the first node of this list. And the temporary pointer is required because here we want to free the memory space for this particular node using the free function. Now this is the algorithm, and now let's code what we have understood. When choice equals 1, that is when the user wants to delete the node from the first place, and since the pointer ptr is pointing to where header is pointing, that is to the first node itself, so to delete that node we can simply write that the deleted item from the list is ptr data, and then we'll change the header to header link. Now else if choice equals to true, that is the user wants to delete the node at some position in between the linked list, then what to do? So let's understand the logic for that case, and then we'll come back to the compiler and code of what we have understood. So deleting a node at the given position. Let us suppose we already have this list and the head is pointing to the first node of the linked list, and here we are supposed to delete the node at position number 3, that is the third node of the linked list, right? So here two pointers will be required, ptr and ptr1. The pointer ptr and ptr1 both initially will point to the first node of the linked list, and both will be required to traverse the linked list. But the pointer ptr will traverse till this particular node only, while pointer ptr1 will travel to this particular node. Why? Because pointer ptr is required to create a link between this node and the last node, while pointer ptr1 is required to free the memory space for the node that we are supposed to delete, right? So pointer ptr will create a link between this node and this node shown by this arrow, while pointer ptr1 will free the memory space for this particular node. So this is the algorithm, and now let's code what we have understood in the compiler. So let's ask the user first to enter the position from where he or she wants to delete the node. We'll use our global variable pause, and now let's traverse the linked list. And also assign the pointer ptr1 to ptr. So now till now ptr, ptr1 and header all are pointing to the same first node of the linked list. To traverse the linked list, as mentioned earlier, we'll write ptr equals ptr link. So after the linked list has been traversed, it is the pointer ptr1 that has got the node that has to be deleted. So we'll write printf the deleted element is %d, comma ptr1 data, and as a final step we'll write ptr link equals ptr1 link. That will create a link between. So the last step will create a link between this node and this node, last node, right? So that will create a link between this node and the last node, while last case will be else if choice equals 3. Then what? That is, the user wants to delete the node from the last place, from the last position, or from the end. Then what? So let's understand the logic for that, and then we'll come back to the compiler and code for the same. Let us suppose we already have this linked list and the head pointer is pointing to the first node of the linked list. Now please note that we only have a head pointer and we can access the linked list only through the head pointer. Let us suppose I create one more pointer, which is ptr, which is also pointing to the first node of the linked list. Now the next step is to traverse the list so that I can delete the last node. So the traversing is done using the for loop, and here we require two pointers. One pointer will stop at the last node of the linked list, while the other pointer will stop at the second last node of the linked list. Why is this third pointer ptr1 required? The third pointer ptr1 is required because we can make the link part of the second last node equals to null using the third pointer ptr1, while the pointer ptr is required because it can simply free the memory space for the node that is to be deleted, that is the last node, using the free function. So this is the algorithm, and let's code what we have understood in the compiler. So let's traverse the linked list. So for that we'll write ptr link, and since we have to traverse to the last node, we'll write not equal to null. So till it doesn't reaches the last node, keep traversing the linked list, and we will keep updating the value of ptr1 as ptr, and then ptr is equal to ptr link. So after traversing a linked list, we have the last node in which is pointed by the pointer ptr. So we'll write the deleted element is, or from the list is, because we wrote this statement, same statement, that's why I'm writing the same statement here as well. It is in ptr, so ptr data. And then because the pointer ptr1 is pointing to the second last node and the link part of the second last node should be now pointing to null, we'll write ptr1 link part of it must be equal to null. So that finishes with the third case as well, and this also finishes with our deletion function as well. Now the last function is void traverse. So I've already written the code for the traverse function. You can check our previous video to understand how we traverse and display the linked list. So for now, let's quickly run the code. So initially our linked list is empty. So let's enter some values in the linked list. So random value, let us say 10, 20, and I want to insert that at the start. Another value I want to insert is 30, This time I want to insert 30 at the end, and let's display our linked list. So it will be 20, 10 and 30, 20 inserted at the start, 30 inserted at the end. Now let's delete the value which is 10, which is at position number 2. So to do that, it will ask the position. So the position is at position number 2, that is the item 10, and here it is displayed that the deleted element is 10. Now if we display the linked list, it will only have 20 as the first element and 30 as the last element. That's it. So let's display it. So the elements in the list are 20 and 30. Let's add 2 elements, one at the start and one at between the linked list, right? So first I want to add, let's say 100, and I want to add this at start, and I want to add another element, let's say 200, and this I want to add at middle, right? So it will ask for the position. So I want to insert 200 at the second position, so I write 2, and if I display my linked list, it will have 200 at the second position, 100 at the first position, 20 and 30 respectively. And let's finally delete the last element, let us say, right? So to delete that last element, we'll simply choose the option number 3, which is at the end, and the deleted element from the list is 30, which was the last element. And if we now display the linked list, it will only have 100, 200 and 20. Here it is 100, 200 and 20. Thank you, and I hope that you have understood the different operations that can be performed on single linked list, and do stay tuned for such informative videos in future.